or we need to run exact transform load process to move data. How can we design this process so it's run fast, so it's scalable? And we don't have much time and resources to do that. And we don't have Hadoop. So what are you going to do? So how many people here are familiar with Hadoop? Anybody using? It's a lot of people. Well, Storm is the same for real-time computations as Hadoop for batch processing. So difference is Hadoop is inherently for batch. Storm is designed from ground up to do real-time stuff. So why we need real-time? First, it's better end user experience. Let's say you display advertisement, personalized, or you see counter move. It's also so-called operational intelligence. You can create different dashboards so your marketing department see what's going on and how campaign doing, how operation people see what's going on. And also you can process events. For example, we're processing events on our website and run rule engine. And based on that, we do some predictions, some personalization. So all this requires massive computing power.
Yeah, I'm trying to do that.
Or even simple example, like a lot of companies now are using most popular article, like trending. What's this most popular article in that last minute, or last hour? That also requires real-time computation. And if you have millions of hundreds or thousands of articles and millions of users, that's a lot of computing power. So if you do it yourself, it's quite complex. So we start looking for frameworks that could be fast, scalable by process parallelization and distribution, fault tolerant, because if something goes wrong, we don't want to fix it in the middle of the night, and guarantee data processing, so no events get lost, easy to learn, code and operate, and of course it has to be robust. If real-time, let's say Hadoop cluster goes down, and you fix it in 2 hours, that's okay. It's batch process, it takes a little longer. But if real-time system goes down, it's not real-time anymore. So here's a framework that satisfies all this condition and even more. It's called Storm, and it's developed by Nas and Mark, and it was secured by Twitter. So now it's called Twitter Storm. So it has all those properties that I described, plus additional. It's run on JVM, and you can write application in Python outside of Java. You can write it in Groovy, Python, Ruby. So it's not limited only to Java. And why it's run on JVM? It's very important because companies know how to run Java virtual machines. They have big experience. And introducing something new will be very hard. So when it's run on JVM, it's much easier to sell to operational folks. If we talk about Storm use cases, so one is stream processing. What is this? It's like when you read some events or you read some data, you process, you save it to database, and you forget about it. For example, you're reading log files. You do something or you do ETL transformation. For example, we're reading events from Mongo database, transform it to relational database, and send it to BI for analytics. Distributed RPC, it's more like when you want to ask complex question your system, and I will talk about that. And continuous computation, it's, for example, trending. What's trending? What's hot in user community right now? So it's doing continuous computation. Here's how Twitter uses Storm. It's used for personalization, for search, for real-time analytics. No surprise, it's Twitter product now. And even Yahoo using it for micro-batch processing of event user, for content feed, application log. And we're using it to move data, for example, from MongoDB into BI. So it's not limited to analytical job. It could do a lot of other jobs as well.
So you come here.
So in order to understand what it does, let's talk about some abstractions that it has. The one is Storm cluster. Because it's a distributed system, it's work in a cluster. So these three nodes. One is master node, cluster coordination, which settles zookeeper machines, and worker process called supervisor. So the job of master node is to get your code and submit it to worker process for execution. It's also monitored. If some worker process goes down, it restarted. So this Nimbus, it's a master. So he knows about everything. And supervisor, it's a process that runs on your worker machine. And that's when it gets code, it's based on your configuration. It will start Java virtual machine, start thread, and start executing your code. And Zookeeper does all coordination between, and also it keeps state of worker machine. Because if worker machine goes down, Nimbus will assign this task to another machine, so it's nowhere to start. And other abstraction is spout, stream, tuples, bolts, and topology. So internal data structure in Storm is called tuples. Well, Java language doesn't have tuples, but basically it's a list. So like colonoscopy and count. Stream, it's sequence of tuple. Spout. Spout is the element that read from stream of data. For example, it's read from your message queue, it's read from your event log, it's read from your database, and create tuples and stream of tuples and send it into your topology. So it's like entrance into your topology. And inside you have bolts. Bolts is processing. It's the component that does processing. So basically it takes tuples, it takes streams, divide it, and create another streams. So meanwhile it can apply function, transformation, calculation. It can access database. You can program it to access your API, filter data, anything that you wish you can do in both. And topology is like a graph where you bring this whole thing together. Okay, so let's see. We said that it's easy to write, it's easy to use. So let's see if it's indeed easy to use. So let's say I want to write application that will read stream of tweets. And I want to calculate how many hashtags will appear in my stream. So this stream is constantly tweets, it's constantly coming, and I want to calculate how many hashtags for each of them happens. So first I have to create spout that will read, let's say I'm getting it from JMS or I'm getting it from MongoDB, doesn't matter where I'm getting it from. And I get the tweet, now I have to split it. It's almost like word counting example, but a little more elaborate. So now I split sentence. So my initial stream now split into 5. Initial tuple now split into 5 tuples. Next component, I want to remove that. I want to filter this hashtag and send it to the next component that will do counting. How many cancer I have, or how many oncology, or whatever. And printer bolt is just bolt I create for demo purposes. Just print system out, nothing special. But you can save it into database, you do a lot of stuff. Also, we will be using local memory, but because it's a distributed system, it's not advisable to use local memory, but for them it's okay. Because if your machine goes down, everything that you have in local memory will get lost. Okay, so here's how to create a spout. First, you extend base rich spout. It's a class provided by Storm framework. And then you have to declare fields, field name. What's will be output? So in this case, we will be output tweet. Then this open method, what it does is basically initialization. You can put some initialization here. And then the whole work done in next tuple method. In this particular case, for simplicity, what I do, I just retweet randomly from string array of tweets. And I emit this value, random value. So here's my array. So I pick up random tweet, random string, and emit it into topology. Even that you don't have to do in a real life. There's so many ready available spouts on GitHub, integration available for Redis, Kafka, MongoDB, Amazon, and many others. So there's a project on GitHub called Storm Contrib that people contribute their integrations. Okay, any questions so far for spout or topology? Yes?
When you showed that topology with the spout and a bunch of bolts, are those bolts individual instances or they're different bolts?
The question was, is those bolts individual instances? No, it's it's just logical diagram. I will go to it and you will see how to make it like, is it individual instance or it's many instances. Yeah, I'll talk. I'll show that exactly. So next, how we create a bolt. So again, very simple. We extend base reach bolt. We have prepare method where we do our preparation or some initialization if we have to do something. And then again, we declare output field, and we have to, in this case it would be board, because we're breaking down this string into boards, and then we have execute method. So you see just in a loop, outputting, emitting these words. So no rocket science here as well. And filter bolt almost the same. It just, again, we declare new field that this bolt will be emitting, this tuple. And again, execute method will be emitting the same. We check if hashtag exists and emit that. Yes?
Are the tuples limited to Java serializable or primitive, or can you put more complex?
No, you can do more complex objects. This even interface you can extend and create your own serializer. Yes, but by default it's limited to Java primitive and some others. Yeah. I successfully serialized without any addition MongoDB object, so that was fine. And here's a bolt that will do counting. In this example, we will be keeping it, so it will emit hashtag and count, and we will use hash map to do the counting, just to keep track of counting in memory. In reality, you probably want to save it to some memcache or MongoDB, some fast memory. And you just, again, emit it. So now you have all these bolts, and you have a spout, and you want to link it together. How to do that? That's what you call topology, how to create topology. So you create topology using topology builder object. Here's in my main class. Then you assign spout, and you create a spout, is that ID for the spout. Then you do bolts. And here you're saying, okay, this bolt called split has to listen from stream from spout. You like chaining them all together. And now you like saying, okay, this bolt called hashtag filter has to listen from split. And the same happens here. So your count, bolt count, listen to hashtag filter bolt. So you like chaining all your bolts. And this also config config object where you put all configuration for your topology. Here I just did nothing, just say debug to false, but you can do a lot of configuration here. And after that, you just say, okay, here's my local cluster, and submit topology to local cluster. What's local cluster? It's clusters that will run on your local machine. So you don't have to have the whole cluster set up to run Storm topology. You can, for testing purposes, for development, you run it on your laptop. And I show you how to run it on the cluster. So, okay, so we did a simple workflow. So what's the story? I mean, there's no parallel processing. We talk about distributing processing and all that cool stuff, and we didn't see it. So let's say I have a lot of tweets, and I want to parallelize my processing. So for example, I want to have 2 spouts. And let's say split sentence bold takes a lot of time. I want to parallelize and run it on 4 instances of this guy, and 6 instances of hashtag filter, and even 8 instances of hashtag count distributed across machines. How I do that? It's turned out to be quite simple. So I want something like this, run across many machines. So all I have to do is put this parameter. It's called, I forget what's the name of it, but anyway, here you specify how many parallel processes you want for this particular component. So I want 2 for spout, 4 for this one, 6 for hashtag filter, and 8 for hashtag count. And Storm will, and also I want to say, okay, run all my component on 2 Java virtual machines. So set number of workers, will be translated in how many virtual Java JVM will have. So if you have 1 machine, Storm will create 2 JVM on 1 machine. If you have 2, 1 of each will be created on each machine, 1 JVM. And the same thing. So how is this parallelism working? So as I said, set number of workers, specify number of work processes, which is virtual machines, right? So parallelism hint, this is number 4. This will tell how many threads for this particular bolt or spout you allocating. Right? So in that case, I allocate for green bolt, I allocate 4 processes. So you see 4 executor threads spread out across 2 Java virtual machines. And you can also specify even how many tasks you want for this particular component. So I said 8, so it will be 8 tasks, 2 for each thread. Any questions? Any? Yeah, I think it's possible. I just don't remember how, but the latest release make it possible. By default, it's make all decision for you. Yes, it's possible, and I will talk about that. Right. I come to this as well, and I show you what's happened, but overall, you have to run numbers under supervision, like in Unix, like DiamondD or something, so it monitors this Nimbus process, and if it goes down, it's a restart. But your topology will still survive, and I showed this. And to your question, it's called rebalance. So this Storm comes with user interface, web user interface plus command line, and you can rebalance your topology on the fly. So let's say you add new computers to your topology, you can rebalance and say, okay, for this bolt, let's do more processes, do more JVM. So it's possible. And Storm UI also have a rebalance feature. Yes, yes, local mode, yeah, for testing only. But you can still test some interaction between balls. No, this is real mode. Okay, and speaking about real mode, the only difference, this is local cluster, and this is if you want to do to submit your topology to real cluster, all you have to do is say Storm submitter. Everything, all your code stays the same. And here how you submit. So you execute Storm jar, and for example, for our topology, hashtag topology jar, what this jar contain? It's contain all dependencies that you use in your application, except Storm, because Storm already exists on machines. So if you use Maven, I think it's assembly plugin. I use Gradle, this is fat jar plugin. So that's how you create jar file and submit to your topology.
Is there like a distributed cache to distribute the jars across all the nodes?
No. No.
Is Storm intelligent enough, or it can dynamically change my parameter? Like, suppose I run a stout or I run a bolt with 8 threads, and it's making my system slow, CPU is getting high, or maybe this read are high, this write are high. So it will change automatically my 8 parameter to 6 or 4 if the system doesn't crash or something.
I see. Auto scaling, it's not implemented yet, but in UI you will see performance statistics for your bolts. Of course, crash, that's a bad, but there's nothing to automatically prevent that from happening.
Couldn't you just let it bolt to rebound?
I don't know. Never thought about that. Actually, the whole Storm written in Clojure. So if you want to write, I think you can write something in Clojure and contribute. Yeah.
So most of the people they are recommending Clojure than Java
No, in Storm, if you develop application, you can develop in any language.
But more focused towards Clojure.
No, until you contribute to Storm project, to go to internals of Storm, it doesn't matter. It's even designed to run different languages like Python or C. So it's make it more like widespread. I use Groovy actually to do all my Storm stuff. So it's worked perfectly. No, you don't have to until you want to. Okay, and last thing about topologies that I didn't talk is shuffle. It's the sentence shuffle grouping. So when you send stream from one tuple to another, you can shuffle it. Let's say shuffle it means you just randomly send it to all balls. Whoever available will pick it up. But also you can do field grouping. In that case, you group your output to be sent to one particular bolt. For example, let's say you want to do real-time calculation. So if you send this cancer word to random bolts, each bolt will have some count, but none of them will be correct. So in that case, you want to group it and send it to only one bolt. And that bolt will calculate total for, let's say, cancer, save it to database. In that case, you will get correct result. So that's why we have this field grouping. There's also other types of grouping that you can use. And you can even create your own if something. Yes?
Have you measured how much CPU the always running processes are using, like the Nimbus and are those using a lot of CPU, or are those?
No, I know that Nimbus, Zookeeper, they're low CPU, very low resource process. They do nothing basically. They just monitor. Workers, that's where you want to see to check everything.
Are there performances between writing in Java and Python?
I don't think so. Maybe there is some, but I'm not sure how big it is. It's thread pool, you manage everything yourself. You have to take Storm as a whole system. Like thread pool is just little piece. Storm is like the whole, like fault tolerant, balls, easy to distribute across machines. So that's a little different concept, I think. So here's a video I just recorded, like in the morning, because I didn't know I couldn't show demo, but let's say how it works. So here's exact from my ID environment, exactly the same. That's what I was talking about. We just will run topology and shut down in 10 seconds. So here's spout, so declare output, next tuple, emit. So here's our bolts that cut off this hashtag and emit it again. And this is a counter. So map, where we store data, and we also emit void and count. I call it hashtag and count. So you always have to declare fields in a Storm, otherwise it will complain that I don't understand what you're sending to me. And I just run this topology. In local mode, it will initialize everything and start working. So here you see tuples, stream of tweets come, topology execute, and give us a result in real time. So counter keep increasing. So if I go back, you will see this counter of hashtags. And because it's random, you cannot see who has to be after whom, but overall you see that it's increasing and it's calculating your topology. And that running in real time. If I deploy it now in EC2, for example, it will run for millions of users for the whole big websites. Okay, so talking about deploying. So when you submit your code to topology, you basically submit it to Nimbus, and Nimbus will take it, send it to your topology to supervisor on each machine, or depending on your settings. Supervisor will start workers, which is JVM, and inside JVM it will start threads, executors, and create tasks. And that's what this command will do, Storm jar. And you don't have to do much.
Just to clarify, so that submits across the cluster?
Yes, yes. Yeah, you submit to one node, to Nimbus, and Nimbus make intelligent decision where to send your code to.
Does it check the load on machines after the fact to do anything without you taking it out? Or
No, I don't think, yeah, I don't think it does. Not in current release. So out-of-box configuration quite good. There is also Storm deploy project, because in a real cluster there is a lot of installation. You have to install Zookeeper, you have to install 0MQ, there is other components, it takes time. But for some of you lucky enough to run on EC2, there is a project called Storm deploy. They claim one click and the whole cluster will be ready for you. And it's easy to use, robust, and also Storm UI is very useful. Speaking about Storm UI, you can see what type of topology you're running. You see topology summary, and you see all details about your bolts, about your spouts, and statistics, how many tuples it's processed, how long it took, some error messages, how many tuples failed. So it gives you a lot of information. And now let's talk about a question about, okay.
Are those statistics available via spouts?
Yes, yeah, for spout, for bolt, for full
I
topology.
mean, are the
Exposed.
is publishing the data as tuples out of a spout? So can I do aggregation and filtering and stuff?
On statistics of your execution? I don't know actually, I didn't try that. But I bet well, it doesn't run any persistent storage. So you may do something, but you have to create something to store it. By default, there's nothing in installations that has storage. Yes, yes, it's one. No. Oh, well, you can if you install everything, but it's designed to run in cluster mode. Yeah, it's a separate process. So what's about, okay.
One last question. Does the storm deployable across data centers? Are we going to try that?
Well, I'm not sure about that. I think it will be a lot of latency introducing by across data centers.
You have to use like Kafka or something.
Yeah. Okay, so the question was before, what's happened if Nimbus goes down? Now we have normal operation, everything nice and cool. So if Nimbus goes down, well, process will continue. Your application will be still running. The only problem, you will not reassign task, you will not create a new topology. This facility will be lost. But your application still runs, and that's important. So if you run under supervisor, then on Unix it will automatically restart your Nimbus. Now let's say the whole machine will die. And nothing big deal. So Nimbus will reassign the task to another machine. So process will continue. Now, one second. If supervisor dies, well, worker is still alive and will perform your task. You just lost like assignment of new task to these workers. And finally, let's say workers dies, let's say GVM out of memory error. So supervisor sitting on the same machine, it will restart this GVM. It's monitoring those, because he initially started this GVM. So he monitors it and he will just restart it. So that brings all this to guarantee message processing. Any question for? Yes. Yeah. Well, in production environment, it's recommended that you run 3 instances of Zookeeper. It's small server, small resources, so it's recommended so you run at least 3. So if it dies, another will be. It's like a cluster of Zookeeper machine. I cannot. I don't know. Yeah, I think it's peer-to-peer. Okay. So, what's your question?
What happens to the data when either the worker goes down, for example?
Well, if you store data in memory, it's lost. So that's why I talked initially, we have to use something like Memcache or Cassandra or some fast database, so you store your data over here.
Is the workers, I don't know the name of the method, but is that method transactional? What happens if the worker dies halfway through the process?
Well, no, it's not transactional. If it dies, it dies. You can lost. And actually, that's what I will going to talk next. Let's say it dies in the middle and it's lost your message, right? So what's happened? So here's what's happening. Storm guarantee message processing. So what it means? It means that let's say we create a tuple, the whole sentence. the cow jumped over the moon, and that tuple create another 5 tuples, and those 6 tuples, and these 6 tuples create another 6 tuples. So it's called tuple tree. So Storm saying message will not be complete processing until all nodes in this tree will successfully processed. So if one of this node will die or something happens to it, the whole tuple will be failed. And there is a special reliability API built into Storm to track that. So what you have to do if you require this type of reliability, first, when you emit your tuples, you have to assign message ID to it. So Storm will know Storm can track each individual tuple. So here I just assign random UI, but you can assign any from your database. I assign from MongoDB _ID numbers. So that facility allows Storm to monitor each tuple. And then another thing you have to do is so-called anchoring. Anchoring is saying, like, every time in your bolt you read tuple and you instantiate another 2 streams of tuple, you like breaking it up, you have to tell Storm that, okay, here's my original tuple and here's my new tuple. So here if you see, I emit original tuple and a new one. So that allows Storm to track all this tuple tree. And that's another piece of code here, it's just without this anchoring. So you have to do anchoring if you want reliability API. And also, when you finishing processing each bolt, you have to tell that I'm finished. So basically here, output collector ACK method, it's telling that I'm finished process. Here, let's say I connect to database and I am fail in the middle, it will be exception and I have to call fail method. So what's happened, this ACK or fail method will go all the way back to Spout. And Spout have ACK and fail method accordingly. So what's happened, you can replay your tuples, your message. So if it's fail in the middle, it goes back to Spout and you can replay it. Or you can save it somewhere for further analysis. So what I was doing, if it's fail, there is no reason to reprocess it most of the time. I just save it into database, into another collection. But if it's successful, you just print, you do something or do nothing, it's up to you. And if you have message queues that allow you to read back, if it's fail and reprocess, you can do it. So fail and, well, question about that before we move to more different topic about reliability API. Any?
Not sure it's quite late, but at the beginning you showed us. My question is, when tuples are arriving, is there any guarantee that it has a single thread code instance of the bolt? Because you had a bolt that had a hash map, there wasn't a current hash map. And so I was curious as to whether that was not necessary because you were guaranteed a single thread of unlimited instance of a bolt.
Yes.
Right.
Yeah. Okay, so we did some real-time analytic with this tweets, but looks like we did too much job for simple task. So what's on top of Storm, what's people in community built, it's called Trident. It's a high-level abstraction on top of Storm to do real-time analytics. So for example, you can do joins, aggregation, grouping, function, filters, and it's also provide you with exactly one semantic. What's exactly one semantic is? For example, let's say you calculate your tweets, and some tweets fail, and you happen to replay it. So now you have two tweets instead of one, so your counter can be off. So that's exactly one semantic, it's guaranteed by Trident. So this is not happening. So for example, let's return to our original example and do it in Trident. So what's the difference will be? So here we use fixed batch spout. This is come with Storm just for testing. What it does, it just emits the same values that I did with array of string, and it cycles endlessly because I say cycle is true. And again, instead of topology, I create Trident topology, and here's the interesting stuff happening. For example, instead of bolt, I'm saying each. Each means for each tuple in my topology, perform, and I call it like tweet, perform split function. And if I look what split function, it just, I don't have to create bolt anymore, so I create a function. But code exactly is the same as I put in bolt. A little less, actually. So I extend base function and emit word. And next is hashtag filter, so next element. And then I group it by hashtags. And here's persistent aggregate. So it's a built-in function, and new count is also built-in function to do exactly this counting that I did before manually with bolt. So it's built in. Persistent aggregate will save it into local memory, but this implementation to save it in memcache as well. And you can create your own. If you use Cassandra or MongoDB or whatever, you can create your own implementation of that. And let me see if I can. Okay, I had a demo here. Let me try to run it. You'll have the same result. Something wrong, but anyway, it will produce exactly the same result in previous demo I did. Any question about Trident?
Is the maturity of Trident the same as with Storm, or I know it hasn't been out as long?
Yeah, it's a recent product, it's actively developed. Oh, yes, it's not mature as this. And
Changing a lot.
yes, it's still evolving. But it's quite cool, and I think people familiar with Hadoop, I think it's something like Pig for Hadoop. That's Trident for Storm. Just bring you a little bit higher level of abstraction to do real-time analytics. And also Trident has this feature called the Rpc Server. What the Rpc Server does, it's, let's say you want to ask your Trident topology some complex questions. Let's say how many tweets I got for the last month. So that requires a lot of power. So it's basically a remote procedure call against distributed computing. So for example, we want to know the aggregate count of tweet with hashtag cancer and physician at this moment. And it's like in real time. Let's say your browser asking these questions. And Storm and Trident via the Rpc server will return this answer. So the Rpc server is just a little guy sitting in the middle, getting argument, like function, getting function and executing it. So for this, I create a little example that print hashtag cancer and physician counted every 1 second and print it out. So the only difference in code from previous example, I have to save state. It's called in Trident state. Here I have to save the state of my Trident topology, and I have to create a new gRPC string topology. And then I have to split my arguments and state query my original topology. And that will return me word and count for my arguments. So here's another sample. I'm not sure if it's running, but output is the same. So you see, with very little code difference, you can create a very complex So, in conclusion, I would say it's allow you to solve wide range of business problem in real time. It's not limited to analytics or big data. You can do transformation, extract, transform, a lot of stuff. You can do a lot of stuff where you can read stream of data, analyze log file. People use it for security, for fraud detection. And this very good open source community, question get answered, it's constantly evolving. Here I have some resources. Also, I started a New York City Storm Meetup, where people who has a lot of experience implementing storm topologies, they will come and share their experience. So welcome to join that. And questions? I think 0 and 2. Yeah.
You know the idea of streams?
No, I haven't. I know Spring now come with something similar. I forget X or something. And also, yeah.